Hi everyone, today we're going to start 10.6, which is find segment lengths in circles. Segments of a chord. When two chords intersect in the interior of a circle, each chord is divided into two segments. So now let's look at the segment of chord theorem. The segment of chords theorem just states that when we divide our chords into two segments, such as chord AB and chord DC, we then figure out that AE, which is this segment right here, times EB, which is this segment right here, is going to equal EC, which is this segment right here, times ED. So make sure you write down this equation in your notes with this diagram. All right, so let's practice that. So we see two chords, and those two chords are divided into four different segments, and the intersection's right here. So let's start with this chord right here. We know that this is going to be 3 times x, which is just 3x, is equal to, and I'm going to take this chord, and it's going to be equal to the multiplication of those two mini segments, and we have 9 times 5. So I can simplify this, so 3x stays the same, is equal to 9 times 5 is 45. Divide each side by 3, and x then is equal to 15. Let's try this again. So I'm going to start with this segment. I'm going to multiply the two parts. So 4 times x is equal to this chord. I'm going to multiply the two segments together, and we have 8 times 6. Let's simplify this. 4x is equal to 48. Divide each side by 4. X then is equal to 12. Let's try a problem that's a little bit harder. We're going to find the segments of the chord. We want to find the length of ML and JK. Well, before we can do that, we need to figure out what is the value of x. So let's start with this chord right here. So we know it's split into two segments, and I'm going to multiply those two segments together. So one segment is x plus 2. The second segment is x plus 1. We know that this is equal to the two segments of this chord, which in this case, one segment is x, and the other segment is x plus 4. Now the goal here is to solve for x, so I need to simplify this by FOILing. So x times x is x squared. X times 1 is 1x. 2 times x is 2x. And then 2 times 1 is 2. That's going to be equal to. And then on this side of the equal sign, I'm just going to distribute that x inside the parentheses. So x times x is x squared. And x times 4, we get 4x. So if you look at this equation, we notice right away that we have an x squared on this side of the equation and an x squared on this side, meaning that they are going to cancel out. I also have x's here that I can combine together. So x plus 2x is 3x. And then we have that plus 2 is equal to, and then the only thing that's left over here is this 4x. So now I can solve for x, and I solve for x by subtracting 3x on each side. And I end up getting that 2 is equal to x. Now remember, we're not done. It asked find the length of ML and find the length of JK. So I actually plugged in x for those equations, and I get one segment here was 2, this segment length was 4, this was 6, and this was 3. So then we get that ML is equal to 4 plus 3, and that is 7. And JK is equal to 2 plus 6, which is 8. Next, we're going to talk about a secant segment. And a secant segment is a segment that contains a chord of a circle and has exactly one endpoint outside of the circle. And then let's talk about the term external segment. External means outside, so it's the part of the secant segment that is outside of the circle. So if you look at this example here, this entire segment here is called a secant segment. However, just this part here, the red part that's outside of the circle, is called the external segment. So the next equation that we want to make sure we draw the picture out, as well as write out this equation, are that if you have segments of a secant, here's the theorem. Segments of a secant theorem just states that AB times EB is equal to EC times ED. So the outside part times the entire segment length is equal to this outside part times this entire length. So let's try an example together. We have a multiple choice question here, and we want to know what is the value of x. So if you notice, we have two secant segments. So we're going to multiply the parts. So we're starting with the outside segment, so 4, times this entire segment length. Well, it's made up of 4 and 5. So when I add those together, I get that the entire segment length is 9. So this is going to equal, now we need to multiply it by the other external segment, which is 3, times this entire segment length. Well, if part of it is 3, this part is x. The entire segment then would be 3 plus x. So let's simplify this. First, 4 times 9, we know that's 36, is equal to, I need to distribute this 3 inside the parentheses, so this becomes 9. 3 times x is 3x. Let's solve for x by subtracting 9 on each side, so 27 is equal to 3x. Divide by 3, we get that 9 is equal to x. So we get answer choice D here. Let's try another example together. All right, so I have two secant segments here. So to figure out what x is, I'm going to multiply the external piece, which in this case is 6, times this entire length, which 9 plus 6 is 15, is equal to, let's look at this external piece, 5 times this entire segment. And be careful here, we have part of it that's 5, the other part that is x, so this would be 5 plus x. Simplify what we know. 6 times 15 is 90. This is equal to, and I got to distribute this 5 inside the parentheses, so 5 times 5 is 25. 5 times x is 5x. Subtract 25 on each side, we get that 65 is equal to 5x. So 13 then is equal to x. And the last theorem that we're going to work with today is the segments of a secant and tangent. So this blue, I'll use this marker, this blue line here, this is a tangent, and this here is a secant. So when you have a secant and a tangent, what you're going to do is you're going to start with the tangent line, and you're going to square that number. And then when we're working with the secant, you're going to do the same thing we did in the last examples, where you take the external piece and multiply it by the entire secant segment. So here we go, let's practice. Which part is the tangent? Is it x or is it 6? Well, we know that this is the tangent because a tangent does not go through the circle, it stops right outside. So that means I'm going to take x, which is our tangent, and I'm going to square it, is equal to, now I'm going to take my secant segment, and I'm going to multiply the external piece, which is 6, multiply that by the entire secant segment, so 6 plus 4 we know is 10. Let's simplify this, so 6 squared is equal to 6 times 10 is 60. So that means x then is equal to the square root of 60, which if you plug this in your calculator, you get approximately 7.75. And here's our last example. So once again, we have a tangent, which is this line right here, and then we have a secant. So to solve for x, I want to square my tangent line, which in this case is x, so x squared is equal to, now I need to look at my secant, what's the external piece? It's this little guy here, so 2 times the entire secant segment, so 2 plus 16 is 18. So let's simplify this. X squared stays as x squared. 2 times 16 is 36. So square root each side, square root, square root. We end up getting that x then is equal to 6. And I know before we talked about when you square a number, you get a positive and a negative number. Only the positive makes sense here because we can't have a negative segment length. So just positive 6 is our answer.